all 5 cards. 5 cards. Are hearts. So I have the deck of cards. I'm just going to take 5 cards, and then I want to know what's the probability that all 5 of those cards are hearts. So what I'm doing is I'm taking 52 cards, and I'm taking 5 of them, right? So the sample space, is, so I'll call omega. It's going to be the set of C, where C is a 5 combination. Of the set of these 52 cards, so of these 52 cards. So the outcomes are all these possible combinations of 5 cards out of these 52 cards. So we want the cardinality of the sample space. That's the number of 5 combinations. It's the number of ways you can choose 5 cards from 52 cards. So this would be 52 choose 5. So now I have this event that all 5 cards are hearts. Let's let E be the event. That all 5 cards are hearts. So I want to find the cardinality of E. I want to figure out how many ways you could choose 5 cards so that all 5 of them are hearts. So I have a deck of 52 cards. How many of those 52 cards are hearts? You guys know? 13. 13, right? So the deck of cards, there are 4 suits. There's spades, clubs, hearts, and diamonds. So each suit has 13 cards. So there are 13 hearts. So if I want all 5 of them to be hearts, then I have to choose those 5 from the 13 hearts. So you'd have this number of ways you could choose 5 cards so they're all hearts would be 13 choose 5. You take these 13 hearts, you choose 5 of them. So if you want this probability of this event E, it's just the cardinality of E divided by the cardinality of the sample space. So that's this 13 choose 5 divided by 52 choose 5. And this should be like 0.000495. Any questions on this? So once you find the probability that all the cards are base cards. So A face card is a jack, a queen, or a king. So we need to figure out how many face cards there are total. So there are 4 suits, and each suit will have 3 face cards because each suit will have a jack, a king, and a queen. So if there are 4 suits and each suit has 3 face cards, then how many face cards are there? 12. So let's let E be nice. All cards, all 5 cards. Are face cards. So if you wanted the number of, I want to know the number of ways you could choose 5, so you have 52 cards, 12 of those are face cards, and I want all 5 of my cards that I take to be face cards. So how many ways can I choose 5 cards from here so that all of them are face cards? 12 choose 5. So you take these 12 face cards, and you pull your 5 cards only from these 12 face cards. And that'll make all 5 of your cards face cards. You can do this 12 choose 5 ways. So this probability of E, it'll be this cardinality E divided by the cardinality of the sample space. This is 12 choose 5 over 52 choose 5. This is something like 0.0003. You guys have any questions on that one? I don't want to raise the problem. So for C, I would define the probability. That all the cards are even. And they say to consider aces 1, 11, queens 12, and kings 13. So let's let E be then that all 5 cards are even. So we need to figure out how many ways you can pull 5 cards from this deck so that they're all even. So I need to figure out how many even cards there are. And then I'll choose 5 of the even cards. So aces are 1, jacks are 11, queens are 12, kings are 13. So how many even cards total are there in this deck of 52 cards? So let's see, you'll have the 2 is even, 4 is even, 6 is even, 8 is even, 10 is even, right? 12 is even. So you don't have these categories, right? So you said these categories are even, right? So for each suit, you'll have these cards from that suit being even. Okay. So you have how many? This is 6. Is 6 in? 6. So you'll have this for every suit. Okay. So for every suit, you'll have cards of these magnitudes. So that'll be 6 times 4, right? So this total number of even cards in the deck is 6 times 4 is 24. Okay, so if I want the cardinality of this event that you pulled all 5 cards from the set of even cards, then how many ways can you choose the 5 cards if they're all even? 24, 25. So if you want the probability of this event E, this is cardinality of E over the cardinality of omega. This will be 24 choose 5, divided by 52 choose 5. That's like 0.01. Like 0.1635. 4. You guys have any questions on this? So let me tell you about compound probability. Compound. So let's consider a compound experiment. With, let's say it has this tree diagram. This tree diagram. So I'll have this. We get not out of here. So I'll have these outcomes. Let me call this top one omega 1. I'll leave it to the 2 point. So these other two will have their outcomes. Right? And then this one will have outcomes. So say this one's omega 2. And this will have outcomes. And this will have outcomes. Plus omega 3. These will have outcomes. This will keep going. So this is omega 4 here. So you'll have some compound experiment. Okay. So in this compound experiment, you'll have strings of sub-outcomes. Okay. So anytime you have a compound experiment and you have a tree diagram, then the sample space is all of